Okay, so now we finally get to the part where we can actually change the midline as well. Okay, so we talked about how we can change the amplitude period and how we find the scale for the x and y axis. The one thing that we haven't talked about is the midline. And the midline was always y equals 0 up to this point. But what if we actually just shifted the graph up or down? That would affect what the midline is. And the way we do that, I'm going to put this in parentheses, is we add some number outside of the sine function. Notice how a is multiplying the sine function. That's our amplitude. When we add or subtract some value outside of the sine function, that actually shifts the entire graph up or down, and that gets us our midline, which is y equals k, whatever that value is. So an example of what that would look like. Let's say I had something like y equals, let's say 2 sine of, let's say, I don't know, 4x, that's inside sine, minus 1. Okay, so we want to find all this information, the amplitude. We want to find the amplitude. We want to find the midline. We want to figure out what the period is. We want to figure out what the scale for x is. Okay, now the amplitude, remember, is the absolute value of a. Absolute value 2 is 2. Now the midline, what this minus 1 does is this minus 1 shifts the graph down 1. That shifts the entire graph down 1, which means the midline also gets shifted down 1 to negative 1. Okay, and that's how easy it is to change the midline. That's all that it is. Okay, and our period, still 2 pi over the absolute value of b, 2 pi over 4, which becomes pi over 2. And now our x scale, I'm dividing pi over 2 by 4, which is pi over 8. Okay, if this trips you up, just think about it this way. You're doing pi over 2 divided by 4, which is the same as doing pi over 2 times 1/4. Okay, that's a bad 4. 1/4. Remember, when you're dividing by something, it's the same as multiplying by its reciprocal. That's where we get the pi over 8. Okay, so don't get tripped up on that basic math. All right, now let's go ahead and figure out what this graph would look like. So the amplitude in the midline helps us figure out what the y scale should be. Well, the only thing is the midline's now down at negative 1. So I got to go 2 above the midline and 2 below the midline. So I actually got to go up to 1 but down to negative 3, and that's because our midline has shifted. Okay, and me personally, I actually like graphing the midline as just this dotted line, so I kind of have it as a reference point. Okay, you do not need to do that, but I find it does help for organizational purposes. Okay, that way I know I'm always returning to negative 1 and not 0, because that is a very common mistake. If the midline has changed, make sure you're returning to what the midline actually is. Okay, so that's our scale for y. Okay, now our x scale, we're going by pi over 8. So I'm doing 1 pi over 8, 2 pi over 8, which reduces the pi over 4. Let me make these a little bit bigger for you guys. So 0 plus pi over 8 is pi over 8. I add another pi over 8 to get 2 pi over 8, which reduces the pi over 4. 2 pi over 8 plus pi over 8 is 3 pi over 8. And 3 pi over 8 plus pi over 8 gets us 4 pi over 8, which is pi over 2, which is, notice, our period. Okay, and now we graph sine. Sine starts at its midline. It's just that the midline has now been shifted down to negative 1, so we start down at negative 1. Okay, so we're no longer starting at 0 because the midline has changed. So we start at the midline, then we go up to our maximum, which is at 1. So notice I'm going up 2, which is the amplitude, going up 2 to 1, down 2 to my midline, down 2 to our minimum, up 2 to our midline. And I can continue this pattern forever and ever. I'm going to go ahead and stop it here. So this would be a rough sketch of our graph. Okay, so that is how we change the midline. All right, so I want you guys to go ahead and try an example on your own. I'm going to try to make this one a little bit not too tricky. So why don't you guys go ahead and try something like, let's do y equals, sine of, let's do 1/2 x plus 2. Go ahead and tell me what the amplitude, midline, period, and scale is, and try graphing this on your own. Go ahead and pause the video here and try that. Okay, so hopefully you went ahead and tried this one. Now the amplitude is actually just going to be 1. Notice there's just a value 1 out here. So the amplitude is going to stay 1, which is the same as the parent function, but the rest is what changes. This plus 2 outside here is shifting it up 2. So the midline is now at y equals 2. Now these two together help me figure out the y scale. So I know the midline is up at 2, right? Up at 2. I'm going to go ahead and just draw a dotted line so I know where I'm returning to. And the amplitude is 1, which means I got to go up 1 and down 1 from this midline. So I'm going to go up to 3 and down to 1. Now the period is 2 pi over the absolute value of b, so 2 pi over 1/2 divided by 1/2 is the same as multiplying by 2, so that gets me 4 pi. So it's going to take a length of 4 pi to complete one full cycle. And for the scale, remember we always take, for the x scale, we always take the period and divide it by 4, which ends up just getting us pi. So we're just going to keep adding pi to the right. So 1 pi plus another pi is 2 pi plus another pi is 3 pi plus another pi, 4 pi. Okay, and now sine, remember, starts at its midline, goes up to its maximum. So up 1, because our amplitude is 1, up 1 to our maximum, down 1 to our midline, down 1 to our minimum, up 1 to our midline. So this would end up being the graph of this particular sine function. Ah, man, I was so close to making it perfect. Now I'm going to try. All right, so this would end up being the graph of our sine function. And it's better. All right. I'm going to go ahead and put an extra one in here. Feel free to try this. I'll go over it in just a moment. So why don't you, I'm going to make this one a little bit more challenging. I'm going to make this one just a little bit more challenging. Let's do y equals -3 sine of, let's say 2/3 x plus 1. Go ahead and pause the video and try this one. Okay, so let's go ahead and try this one out. So our amplitude would end up being 3. Remember, the negative is just telling us that it's reflected, so we should remember, that should alert us, and maybe right off to the side, hey, it's reflected, go down to minimum right away. Down to minimum right away. Kind of write a note to yourself. Okay, so that's our amplitude. Our midline is going to be y equals 1, because we got shifted up 1. Now, the reason this is also a little tricky is because now you're going to be dealing with some weird fractions, okay? So our period is 2 pi over b, or the absolute value of b, which is 2/3. And this would end up becoming, remember, dividing by a fraction is the same as multiplying by its reciprocal, which would end up getting us 3 pi. Okay, so the period is going to be 3 pi, which means our scale is going to be a little weird. Our scale, take our period, divide it by 4, is 3 pi over 4. Okay, so we have all that information. Let's go get to graphing this. All right, so our midline is up at 1. So I'm going to go ahead. Ooh, that's bad. I'm going to go ahead and just kind of draw a dotted line going along there, whatever. All right, and our amplitude is 3, so I got to go up 3. So I got to go up to 4, and I got to go down 3, so down 1, 2, 3. I got to go down to -2, okay? Now, our x scale, well, we're going by 3 pi over 4, so I add 3 pi over 4 to 0 to get 3 pi over 4. Add another 3 pi over 4 to get 6 pi over 4. Add another 3 pi over 4 to get 9 pi over 4. And I I add another 3 pi over 4 to get 12 pi over 4. So that's what I was meaning. It's just a little bit weird looking, seeing it jump by 3 pi over 4. And now what we'd want to do is reduce any fractions that we can. So this would reduce to 3 pi over 2, and this would reduce to 3 pi. All right, so this would reduce to 3 pi over 2. Oop, let me change that. 3 pi over 2. And this would reduce to 3 pi. Okay, so we start at our midline, which is 1, and now we go down to our minimum, down 1, 2, 3 to our minimum. Amplitude was 3, so I go down 3 to our minimum, which is at -2. Then I go up 3 to our midline, go up another 3 to our maximum, which is occurring at 4, and down another 3 to our midline again. So this would end up being our graph. Okay, so that would end up being our graph. All right, so just be careful with fractions and make sure you're practicing this. I'll go ahead and record another kind of bonus video with a few extra examples if you want to check that out. Okay, so make sure we are practicing this.